Hey there and welcome. If you've ever stared at a trigonometric expression that looks like a total mess and wondered where to even begin, you are in exactly the right place. Today, we're going to crack the code on simplifying these complex-looking problems. So let's jump right in. First up, we're going to talk about what simplify even means in trigonometry. Then, I'm going to give you a super powerful 5-step playbook to tackle any problem you see. Of course, we'll see it in action with a few examples, cover some common mistakes you definitely want to avoid, and then we'll wrap up by connecting all this math to the real world. So let's get right to it. The first hurdle is often just the instruction itself. Simplify. What does that even mean? It can feel pretty vague, can't it? I get it. It's so easy to feel lost. You've learned all these different identities, reciprocal, Pythagorean, you name it. And now you're looking at an expression with what feels like a dozen different ways to start. So, which way do you go? Yeah, it can be totally overwhelming. Okay, but here's the core idea. Simplifying just means using your toolkit of algebra and trig identities to basically make the expression cleaner, shorter, and just way easier to work with. Our goal? Get it down to the fewest terms we can. Ideally, just one single thing.
So how do we do that without just guessing and checking? We need a game plan, a reliable strategy that's going to work every single time. And that, my friends, is where our playbook comes in.
And this is a huge mindset shift. Look, instead of trying to cram dozens of identities into your brain and just hoping for the best, you need to focus on a clear, logical process. Strategy beats blind memorization every single time. All right, here it is, your 5-step playbook. Step 1, convert everything to sine and cosine. Step 2, combine any fractions or multiply things out. Step 3, hunt for those powerful Pythagorean substitutions. Step 4, use those algebra skills to factor the expression. And finally, Step 5, cancel and simplify. This is the exact process we're going to use from here on out. Okay, I really want to pause on this for a second because this is the single most important piece of advice in the whole playbook. Seriously, if you remember nothing else, remember this one thing. Writing everything in terms of sine and cosine is your best first move. It will almost always set you on the right path. It's the absolute golden rule. All right, theory is great, but let's see how this playbook performs in the real world. We're going to walk through 3 examples, starting pretty basic and then ramping up the difficulty. Let's kick things off with this expression, sine theta cosine theta plus sine theta. Now, it looks pretty simple, and it is, but it's a perfect way to show you how step 4 of the playbook works. Okay, let's run the playbook. So, step 1, convert to sine and cosine. Well, it's already done for us. Steps 2 and 3 don't really apply here, so we can jump straight to step 4, factoring. So we ask ourselves, is there a greatest common factor? And yeah, it's clearly sine theta. We pull that out, and what are we left with? Our final simplified answer, sine theta times the quantity cosine theta plus 1. And just like that, we're done. Okay, let's level up. Here we have a fraction, cosine squared theta divided by 1 minus sine theta. Now this one is going to make us use a few more steps from our playbook. All right, let's run the playbook. Right away, you should see that squared function. That is a huge flashing sign for step 3, Pythagorean identities. So we're going to swap out that cosine squared theta for what it's equal to, 1 minus sine squared theta. Okay, next up, step 4, factor. That numerator, 1 minus sine squared theta, should be screaming difference of squares at you, a squared minus b squared. And that always factors into a minus b times a plus b. So our numerator turns into 1 minus sine theta times 1 plus sine theta. And look at that. It sets us up perfectly for our final step, step 5, cancel. The 1 minus sine theta on top and on the bottom, they cancel right out. And what are we left with? Just 1 plus sine theta. Beautiful. All right, you ready for the final challenge? Let's see how this all comes together. We need to simplify 1 over sine theta minus sine theta. This one's going to make us use pretty much the whole playbook. Okay, let's start running the playbook. Step 2 tells us to combine fractions. To do that, we need a common denominator, which is obviously sine theta. That gives us 1 minus sine squared theta over sine theta. And as soon as you see that numerator, 1 minus sine squared theta, your brain should be yelling, step 3, Pythagorean identity, because 1 minus sine squared theta is just cosine squared theta. So now our expression is way simpler, cosine squared theta over sine theta. We're close. To get to the final answer, let's just break that fraction apart a little. Think of it like this. It's cosine theta over sine theta times another cosine theta. And what is cosine over sine? That's right, it's cotangent. So our final simplified answer is cotangent theta times cosine theta.
Okay, so now that you have the playbook for success, let's talk about the anti-playbook. These are the common traps, the mistakes that can totally derail all your hard work. And trust me, knowing what not to do is just as important as knowing what to do.
Okay, this is the big one. I see this all the time. You absolutely cannot cancel individual terms that are being added or subtracted. Look at the don't do this side. You can't just slash through the sine thetas. That's completely illegal in algebra. Remember, you can only cancel common factors, things that are being multiplied together. Like you see on the right, you'd have to break that fraction up first to simplify it properly.
All right, the second big mistake is just stopping too early. Anytime you make one move, you have to ask yourself, can I go further? Is there another identity I can use here? Can I factor this thing anymore? You've got to keep pushing until it's down to a single term or one single fraction. The most simplified answer is usually the most simple you can get it, so don't leave the job half done.
So why? Why do we spend all this time learning how to juggle these abstract-looking expressions? Well, it turns out this skill is actually a key to understanding the fabric of our universe.
Think about it. From the orbits of planets, to radio waves, to music, so much of our world is described by these repeating, periodic functions. And the people who work with this stuff, physicists, engineers, you name it, they have to be able to handle these complex trig expressions, because by simplifying them, they uncover the hidden patterns, the simple elegance behind how these systems actually work. It's literally how we turn a complex mess into a simple, powerful truth.
So the next time you're simplifying one of these expressions, just remember, you're not just doing a math problem. You're actually practicing the skill of decoding the universe. And that kind of makes you wonder, doesn't it? What other hidden connections is math just waiting to show us?